if I were to name this here O, this point here, if I were to name it A, and if this is B, transferring these 3 points onto this diagram, here will be O, this will be A, and this point here will be B. So in order for us to come out with an equation in terms of H, what we are going to do is first let's try to quote OA based on this diagram. OA is half of A. As for AB, because AB, this length, is going to be the same as this length, so to find AB, we can take 30 minus away A, and that will give me this plus this, and I'll divide this by 2. So AB is going to be equal to 15 minus half A. And then now focusing on this triangle, knowing OA is half A and AB is 15 minus half A, we can make use of the Pythagoras theorem because there's a right angle here. So H squared is going to be equal to this hypotenuse AB squared minus away OA squared. So we will have a 15 minus half A squared minus half A squared. So this is going to be equal to 15 squared minus 2 times of 15 half A, then plus half A squared minus half A squared. So they will be cancelled out, and I will be left with 15 squared. This is 225, and this is going to be equal to minus 15A. Shown. The volume V of the pyramid is going to be 1 over 3 base area, which is a square, so A times A square multiplied by the height H. And if we were to try express V in terms of A, that means H is going to be replaced by square root of 225 minus 15A, which means that the process of finding dV dA is going to be complicated. We're going to do an improvisation. Let's try to square both sides. So I will have a 1 over 9 A to the power of 4 H squared, and H squared can be directly replaced without doing the square root. So it can be replaced by 225 minus 15A, and V squared can be expressed as, if I were to factorize out 15, I will have a 15 over 9, and if I were to multiply A to the power of 4 in, this will be 15A to the power of 4 minus, since we have already factorized out 15, so this will just be A to the power of 5, and this is definitely way easier to differentiate with respect to A. So on the left hand side, implicit differentiation, 2V dV dA, and on the right hand side, 15 over 9, differentiating this, 60A to the power of 3 minus 5A to the power of 4. Let's try to do a bit of simplification. So 2V dV dA is equal to, if I were to factorize out 5A cubed, it is going to give me a 75 over 9A cubed. And then here we have a 12 minus A. And we are going to be letting dV dA be equal to 0 since we are trying to maximize the volume. So letting dV dA be equal to 0, that means this entire left hand side is going to become 0. So we will have a 75 over 9A cubed, then 12 minus A, this is going to be equal to 0. So A will be equal to 0, or A will be equal to 12. A cannot possibly be 0, or else there will be no pyramid at all. So A has to be equal to 12, and since we do not need to verify that it is a maximum, I can just use it as it is. So to find the maximum possible volume, I'm going to let A be equal to 12, and the volume is going to be equal to square root of this. Okay, so it is going to be square root of 15 over 9, then 15 A to the power of 4. So 12 to the power of 4 minus 12 to the power of 5. So the maximum possible volume is going to be equal to square root of, here this is 103,680, which can be simplified to 144 square root of 5. The total surface area of the 4 triangles will be 4 times of the area of one triangle, and that is going to be half times base, which is A, height, which is going to be h. So S is equal to 2AH, which I'm going to make use of what we have found in part 1. H is going to be replaced by 15 minus half A. So the total surface area is going to be equal to 30A minus A squared. Let's find DA, and this is 30 minus 2A. So when the surface area is maximum, we are going to be letting ds, dA to be equal to 0. So 30 minus 2a, this is equal to 0. This tells us that a is equal to 15. And that's it. Since the question says that we do not need to show that this is going to be the value of a that causes s to be maximum, so a is equal to 15 is our answer. From the previous part, when the total surface area of all the triangles is maximized, we know that a is equal to 15. So this a here becomes 15, which makes h 30 minus 15 divided by 2. So this height here, this length here will now be 15 over 2. In fact, this is also going to be 15 over 2. So if this is 15 over 2, this is 15 over 2, and this is a right angle, that tells me that this angle here must be 45 degrees. The same goes for all these angles here. They will be 45 degree, which means that we are going to be getting this as straight lines. So the net from this shape is going to become a square. Let's calculate the sides of the square. So the side of the square is going to be CD, and for CD we can make use of this triangle 15, 15, and here being a right angle, using the Pythagoras theorem, CD is going to be 15 square plus 15 square, which is equal to 15 square root of 2. So the net will become a square that has sides 15 square root 2.